Hey guys, how's it going? I hope everyone's doing well, and I'm looking forward to this stream. It's going to be a pretty cool one. Couple things. First of all, I did change up the layout of like my stream, and I took heavy inspiration from Java X9. So if it looks similar, that's why. But in this stream, what I plan on doing is procedural generation and culling. So hopefully we'll get around to that, and it'll be pretty cool. And how is it going, Jan Poon and Hilbert Curve and SE Woods and Voxel Riffs? It's good to see all you guys. So before I start this stream, I'm just going to go over a couple things that I changed off camera. The last stream we left off with the ability to add new blocks pretty easily. So I did add a couple more block types into the game and stuff. You can see that I got sand, dirt, and then at the top I have like moss blocks up there. So that's pretty cool. And then if we look into the main file, I sort of changed the way that I'm setting up the game and everything. So let me just go into there real quickly. Okay, so, and how's it going, Vixlar? Cool. So inside of here, we got this Minecraft application. So I sort of refactored things just to make it a little bit clearer and like have less clutter in the code and stuff. So the entry point is this run function, which basically just goes ahead. It creates a window. I've abstracted some of the window logic inside of like a window namespace and structure just to make it a little bit easier. And I should stream Sci and Tech. I'm not sure what that is. Okay, but then we got this window. And what's up, Andrew? And we set vsync on, and then we initialize the world, which just goes ahead. It loads the textures from our texture format that we created and the block formats. Then we get a shader. We generate just one chunk for now, set up the render state, get all the camera stuff set up. And speaking of this, I'm going to move the camera's position. I think the Z coordinates, no, I think Y is like our up and down. I'm going to move it up to 100 just so that I start off a little bit higher. So if I rerun this, we should start up. Yeah, okay, cool. So now we're higher up in the world and stuff. So yeah, we set up the camera and everything. And then if we go back into application, we can sort of follow the rest of this. So we initialize, and then we start the game loop, which basically just runs until the window should close. And then we get all the delta time and stuff and update. So that's just a brief sort of overview of where we're at. And will I make inventory and system? I will. We're not close to that yet. This stream is just about procedural generation and culling. So we'll eventually get to that stuff though. And the stream category, science and technology instead of Minecraft. Okay, yeah, I will change that because I wasn't sure like what category would be best for this. I was looking for like programming, but Twitch doesn't just have programming category. So thank you for that suggestion, and I will fix that up for the next stream. So, okay, but yeah. So we basically just have this game loop and everything, and we sort of get everything rendering, and we just have one chunk generating at this time. The first thing that I want to do in this stream is basically just set up so that we fix this stuff, which is if we go inside of the chunk, we're generating all these extra faces inside, and it's not good. So we need to cull all those faces because otherwise we're drawing a lot of random stuff, and that's not good for like performance and everything. So we can do that pretty easily with just a little bit of forethought. So I'll probably switch over to the drawing screen real quickly just so that we can sort of see how this is going to work. So let me switch this over. This does not involve too much math. I mean, I guess it involves a little bit of math, but it's really not that bad. I don't know. We'll see. So basically, I like to draw things out before I start just so that I know sort of have an idea of how this will work. The problem we're facing right now is we've got like a bunch of cubes, right? And what ends up happening is if there's a cube over here and there's a face between these two cubes, right? And you can sort of see that this drawing is horrible, but there's that face between the cubes, and we don't want to draw that face because it's in between them, right? How the heck do we remove this one? Well, it's actually a pretty simple answer, right? We know this cube's position just because it has it stored in the array and stuff, right? So he has like some X, Y, Z, and we just want to look to the left and see if there's a cube here. So that's literally the whole premise of this. It's not really that complicated. We just have to go one to the left, which would be the x-axis in this case, I believe. So we look one to the left, and then we see if this block is transparent or not. So like if this was a glass block, then we would still want to draw this face because you can still see it. But if it's not transparent, then we can just not add this face in. So that's literally the premise of how we're going to do this. It's probably going to get more complicated when we get to like custom stair blocks and that type of stuff. So we'll have to see how that goes. And math is the best. Math is, if you work at math for a little bit, it gets easier, I promise you. So sometimes it takes a little bit just to get used to it and everything, but I think anyone can learn it with enough practice and stuff. So, okay. But anyway, so that's the premise of what we're going to do. So I'm going to go into chunk.cpp where we're currently generating the chunk. And basically what we can do is this is where we actually generate the vertices and the indices and all that stuff. And you can see here that I've labeled everything pretty easily. So we have the top face, the right face, forward face. And we basically just want to remove these for the faces that we're not adding. Now this might pose some problems with the way we're generating this. I do have to think about this a little bit because we basically have this element offset, and let's see. And I also have like the vertex offsets and everything, and those are just standard. And so we probably don't want to be calculating these anymore because they could change. So we're going to have to do sort of like a vertex counter and an element counter. Okay. And are you checking for a block on all 6 sides? I will, because that's just the best way to do that. So we'll have to check all 6 sides. And a suggestion, if I can make a tutorial on how to create a game engine. Well, I have good news for you. If you go to my YouTube channel, you'll find one exactly on that. But am I going to do culling and not greedy meshing? Yeah, I'm going to do culling because we might experiment with greedy meshing in the future. I don't know. I'm just not convinced that there's that much more of a performance increase. Minecraft is already so low poly that it's like doing greedy meshing is probably a bit overkill, I think. I don't know. We might experiment with that and stuff and see how it goes. But for now, just culling. So basically, I want to change the way that I'm calculating elements and vertices because we can't just do this anymore. This isn't really going to work. Where I basically just sort of go into the vertices and yeah, get the offset and the element index. So there's actually a really easy solution to that. I can just say int vertex pointer. I guess that's, yeah, we'll call this cursor because pointer is kind of misleading. So vertex cursor, which is basically just like which vertex we're on, and then int element cursor, which is which element we're on. So we start at 0 and we just increase that for every vertex we add or every element we add. And then inside of here, we are going to do, so we generate 8 vertices, which is good. And then we get the vertex offset, which is no longer going to be this because we're calculating that. So I'm going to comment this out and this out. And right now, what we should end up with is sort of the same thing that I had before. And hopefully, I won't break anything. So just sort of refactoring, and then this way we can add in the culling afterwards. Okay, so we've got the element offset here, and we are not going to need that either, I believe. So we're probably going to have to do like a int element offset. Oh, wait, no. So element cursor is the offset, and then this element index is a little bit different. So then I'm going to do element index cursor, and we're also going to set that to 0. Okay, so now with all of that, we should be good. Cool. So we'll say if the element cursor is greater than that, then we'll log because something's broken. And then otherwise, we will go ahead and set all of this stuff to element index cursor, and then set all of this to cursor. That should be good. And then we'll set all of this to index, or just cursor, like that. And I believe that should be good too. The problem we're going to have here too is we're generating all the elements for all 6 sides. And we may have to skip a couple sides. So I might expand this and just put it down here with all this stuff. So we'll see how we do that. And if after finding a face to cull the face of the other block too. Yeah, we could potentially do that. I don't know if that'll be any, because finding the faces to cull is going to be relatively easy. We're just literally going to have like an if statement here. So we're just going to be like, if the block to my top is transparent, then cull this, or is not transparent or whatever, because we sort of check everything here. So if we just loop through the array, it should be just as fast as if you like culled that one and then you also culled this one. So I don't think we should run into too many problems with that. But yeah. Okay, so we've got these cursors now instead. And we're probably going to have to change this up because this won't work. But for now, I'm going to leave it and not care. So we're also going to change this to vertex cursor. And I'll just copy that. And we'll go ahead and paste it over all of this. All of this. I guess I could do a find replace, but I don't really care about that too much. So we'll do this too and this too. Okay, cool. And then for each of these, we'll want to do like vertex cursor plus equals 4. And then I'll probably want to change all of these to like 0, 1, 2, 3, 4 again. So that we're just incrementing it for every single one we add. And then copy that, paste it. So I'll just paste that all over here. I guess we could probably turn this into a function too. Maybe I'll do that in the off time because I'm not sure if it's worth it, and I'll have to like sort of experiment with that and stuff, but yeah. Does everyone here know what Perlin noise is? I don't know. But we will be using Perlin noise. We might be using, I think it's like Perlin X noise or something. It's something new that Perlin generated, or he created like a little bit later. So Perlin noise was used in Tron, and then he created something a little bit later in his life that was faster and behaves basically the same. So we might use the new improved version. Okay, cool. So we got that vertex cursor thing all set up. And then we also want to make sure that we say element index cursor plus equals 6, and then element cursor plus equals 4, I believe. Yeah, 4 is what it looks like. Cool. So spell that right. Nope. Element. Okay, there we go. Spell that right. Cool. Let's see if we get the same thing. So this shouldn't have changed anything. It's just sort of changing the way we're generating. And we still get a chunk. Cool. And it looks like it's almost right. Okay, nope, I broke something. Yep, so it looks like our side faces are broken. I will see what we did there. So I'm guessing it's probably the elements. So this should be plus 6 because we added 6 in here. And then for this, I'm pretty sure this should be plus 4. So we've got cursor plus 0, 1, 2, 0, 2, 3. So we should be incrementing this by 4 every time. And let's see. We set it to 0 up here, so that's all 0, which should be good. And then we just sort of increment them for every one we do. Maybe I did mess something up here. So this is plus 4, 0, 1, 2, 3. Then plus 4, plus 4. Okay, yep, that all looks right. And then we do plus 4 there. I probably should have done this in 2 steps to make sure I didn't mess anything up. Probably should have done this first and then that, but it's too late now. So, well, actually, no, it's not. Okay, so I can just do this. So I'll do this again, and then we'll change all of element index cursor to element index. So we'll replace those, and then we will replace all of element cursor to element, what is it called? Offset. Yeah. Okay, cool. So I'll do that. Let's run this again. If we get the correct result, then that means I'm definitely messing something up in the elements. Okay, so we did that, and it definitely looks correct. So yeah, I'm definitely messing something up in the elements. Okay, cool. Well, that's good because that narrows things down. Debugging 101, right? So I'm going to remove, actually, I'll keep that for now just in case I break something again. But is there any way to program CPP in Android? Yeah, I have a feeling there probably is because Java was built using C++ and has C++ bindings that you can do and stuff. So should be able to do like C++ for Android programming. All operating systems and stuff are built in C or C++ generally too. So like no matter what operating system you're using, C++ should be able to port to it, which is one of the reasons why it's desired for like game programming. But yeah. Okay, so we definitely have something wrong in here. This says index cursor times 6. This is going from 0 to 6. Okay, maybe, Okay, yeah, because this is just generating 6 faces. Okay, so this is generating 6 faces, which is why we're multiplying by 6 and then going up 0, 1, 2, 3, 4, 5. And then we add 6 every time, which that makes sense to me. Oh, and then I think this should probably be outside of the loop. We should only be doing that once after that. Okay, so if we just move that outside of the loop, I think we should be good. No, that definitely did not work. Okay, we broke something else too. But I think we're getting closer. Okay, let's move that back in. I definitely think it's probably this cursor part that's wrong. So we go 0, 1, 2, and then 0, 2, 3. Oh, wait, yeah, so that was right. This does need to be outside the loop, and then we need to add, so this is going, we add 4 every time, but we're going 6 times, so that's 4 times 6, which is 24. That's what we should have done. Okay, so now I think it should be good. No, that was completely wrong too. Okay, I think we're getting closer, possibly. I just have to remember what my rationale was for this. So we're going 0, 1, 2, then 0, 2, 3. And this is going I times 4. Yeah, I would assume that this would go like 4 times 6. Let's comment out all of that stuff. And then we'll put some semicolons in there. And then I'm going to do element cursor here plus equals 4. Let's see what happens there. I think it should be the same as when I was doing this. But I just want to see. Yeah. Nope. Okay, so that did the same thing. Okay. I'll get this eventually, don't worry. So I just have to remember what this all means. Okay, so this is definitely the faces. I'm going to go back to my drawing and reference that because that'll probably help us out. Okay. I'll show you guys what I'm looking at too, just so that you know. So back in here. So I have these faces and I'm just trying to figure out what order I did this in. So it looks like I'm going 0, 1, 2. So like that. And then 0, 2, 3, like that. And I'm doing that for every face. So then for this one, it would be like that. And then it would be like that. The only difference is I need to increase the element I'm using because it's going to be a different vertex, I think. And then I also need to increase I or something. So basically, this is what I'm trying to do. We'll see if I actually get this right or not. Let's switch back here. Okay. It's kind of early in the morning here, so I'm still kind of waking up and trying to figure this stuff out. So I'm going to take this back in. How did we... Okay, so we computed this by doing array expansion times 36. Why did I do... So 6 times 6 is 36. That makes sense, yeah. And then see, this is times 24. So this would make sense to be 24. At least I would think. Yeah, I'm pretty sure. Let me try this one more time. So I don't know if you guys ever do this when you're programming, where you just keep trying the same thing, hoping it'll work, but you know that it's probably not going to work. Okay. So this is this one, which is this times 24. So we should be adding 24 every time. And then this one should be adding 36. Oh, maybe I should have this inside the loop. Maybe. And then this should be, I don't know what this would be plus then. Yeah, because it's not changing inside of here. So I would assume it would stay the same. Maybe both of these have to be outside the loop. Let's try this. Okay. And yes, I am using OpenGL. So, okay, that did it. Cool. So I just had to move both things outside of the loop. I guess that kind of makes sense, because if I mess one of these up, then it kind of messes with the other thing. Okay, so we can get rid of this now and have faith that I didn't break too much. So I'll get rid of that and we should be good. And now we want to basically check to the left or to the top. So let's do the top first. We'll kind of do this incrementally, since I kind of learned from my mistake and I don't want to mess things up again. So if we're at the top base, what we want to do is we want to check the block above us. First of all, what I'm going to do is I'm going to get this thing into a function so that we can use it. So this is basically expanding from 3 dimensions to 1 dimension. So we'll call this int 3D array. Well, I guess I can't do that. So this should be 2 1D array. Float, or I guess this should be x, y, and z. And this will basically just return this. So return all of that. So it just expands it in place for us. And I think I might be missing parentheses. Nope, that looks good. Okay, cool. So then if I change this, we should be good. So that's 2 1D array. And this will take x, y, z. Okay, cool. So this should be able to like index into our array easily now. And I will also change it up here. 2 1D array, x, y, z. Make sure that I did not break that while refactoring. And you saw my math animation library. Yes. So it probably will end up being a lot similar to, well, pretty similar to 3 blue 1 browns. I don't know. I just find it easier to code it myself, and I like that. So I think it's kind of fun, and it's pretty cool. I've got it so that I can animate arbitrary shapes and stuff using parametric equations, which is kind of cool. So I'll see how it goes, and hopefully I'll get to release a cool video about that for you guys on font rendering. So I wrote up some notes and everything, and hopefully I'll have that in production pretty soon. And in case you guys are wondering what Voxel Riffs is talking about, is the math channel 3 blue 1 brown has basically created a challenge for YouTube creators to like make videos over math things. So I'll hopefully enter the challenge with a video on how font rasterization works, which is pretty mathematical and will hopefully be an interesting video to watch. But yeah. So, okay. So anyways, we've got this. We're going to work on the top face first. We're going to say const int top index equals 2 1D array. And we're going to do x, y plus 1, z. And we have to make sure that this isn't going to be out of bounds. So I guess we should probably clamp this. So we'll say glm clamp from that. Or actually, we could clamp it inside the array. That's probably a little bit of a better idea. So we'll go up to here. And when we're doing this, we'll say glm clamp. So we'll do that. And this takes in x, min val, max val. Okay, yep. So the minimum value we can do is 0, and the maximum value we can do is chunk width times chunk height times chunk depth. Okay, so that way we just don't get an array out of bounds, which in C++ is not fun. So hopefully we should be good there. This should give us a proper index. The only problem we might have with that approach, though, is Here, yeah, I'm not going to do that actually. Because the problem we might have is like, if you're at the top of the chunk, then this could return another block, and then you would think that you have to actually like cull the face when you don't really want to. So instead of doing that, what I'm going to do is we'll say int return value, or I guess index equals that, and we can remove these. And then we'll say return index is greater than chunk width times chunk depth times chunk height, or index is less than 0. So if either of those is true, we'll return -1. Otherwise, we'll return index. Okay, cool. So -1 should be like our flag value, and then I guess I could like create static const int null block equals -1, and then we can replace this here. Cool. So we have a null block, and if we get the null block, then we just automatically draw that face. So we'll say if top index equals the null block, or the top index is not transparent. So we need a way to see if a block is transparent, which we currently don't really have. I think if we look inside a chunk.h, we kind of have a block format, which gives us data about each block, but it doesn't really, or I guess that's on chunk.h, maybe it's in world.h, or maybe I put it somewhere else. Let's see. Okay, let's go into here. I think this is going to be inside of core. Nope, inside of world. Block map. Okay, that makes sense. Cool. So we have this block map thing, which has a block format, texture format, and then this block map. The block format, I guess we should add in a value that's like bool is transparent. And we can add like a bit set and then set a bunch of different things in the future and stuff. Will I implement shadows in the game? Hopefully. We'll see how far we get, but I want to basically make this pretty comparable to the actual Minecraft game, because I followed a tutorial a long time ago, and it was about how to code Minecraft, and it taught me a lot, but they didn't have an inventory system. They didn't have like half the stuff that Minecraft has, and I was so disappointed at the end of it. I was like, this is crap. So I don't want to do that to you guys. We'll hopefully build the whole thing. It's definitely going to take a lot longer to make this tutorial series though, because I want to put a lot more effort into it. So it's probably be like one video every 2 weeks at most, which kind of sucks, but you know, I have to do a trade-off. So I hope you guys will appreciate that. But yeah. And only one side texture for a block format. Yeah, so we might change this up. I was thinking about this a little bit. If we look at the YAML file right now for our block formats, which I believe is right here, this is sort of how we're defining new blocks right now. So you can see like I have grass block, and then I define what the side is, what the top texture is, what the bottom is. I want to do like a block type here, and then this will have like cube. And so if it's a cube, then we'll assume like we could have a certain format, and maybe I could do like left side, right side, front side, back side. But for now, I'm going to leave it this way because I think most Minecraft blocks have like the same sides, except for like crafting tables and a few other blocks. But yeah, so we might change that up, and then depending on the block type, we'll have different parameters here. So like if the block type was like a stair, then we have different parameters for the textures, because that's going to be like a whole different sort of thing. I think it's like one texture, but it's sort of set up differently. So yeah, that's my plan, but we're not there yet. We'll get there in a little bit, hopefully. And it was just a voxel engine. So yeah, probably for the tutorial, the tutorial I followed was specifically how to code Minecraft. So I was expecting like to code Minecraft, but they didn't do that. So it was disappointing. Okay, anyways. So we have this bool is transparent thing now. And what we want to do, I think block map, yeah, we can get a block format by getting the block ID. So what we can do is we can say const block format top block equals block format get, nope, I'm doing the wrong thing, block map. So this should be block map get block, and then we'll get the top index. And inside a block format, or block map now, so block map.cpp, I'm going to add in support for the null block, and I guess this should probably be inside of block.h because that makes a lot more sense. So let's go back into here, and we've got, or I'm sorry, into here. And we've got the null block up here. And I'm just going to remove this from here, and we will put it inside of block map H. And we'll say extern int null block, and then we can implement that. We can't put that in here, but we can put it inside the CPP file. And I believe I put that inside of Minecraft. Yeah, I'm going to move this into the namespace block map just because I feel like that makes a little bit more sense. Okay, so then we put it inside there, and then inside of the namespace right here somewhere. Oh, okay, it's right here. Cool. Then we can do that, and then equals -1. So the reason I do this weird kind of syntax, I guess, too, is it's like my own C++ idiosyncrasies, I guess. But I like to do this just because I don't like using classes that much. I like to use structures in plain old data as much as possible in namespaces. And so this is sort of like declaring a global variable that's just inside this namespace. And so the extern keyword lets C++ know, hey, I have this thing and I only want it declared once. So I only want one of these in the whole engine. And then we declare it again inside of the implementation file. And that sort of lets it know this is what the value will be. Yeah. I'm not sure if I could declare this const, which would be better. Yeah, it's going to give me an error because then I would have to define it inline, which is impossible since this is going to be in a header file. So yeah. And is the transmission frozen? Hopefully not for you guys. So with all that done, we can go back into chunk and we'll just change this to block map, null block. And we'll go back down to here, change this back to block map, null block. Okay, so now we can finally do this. So if the top block is transparent. So if we have a null block or a transparent block, we will add the face. Supposedly. We'll see if this actually works. One thing I want to do too, though, is what I was originally going into here for. Okay, so get block. If we have a block ID, we should say return block ID equals null block. If it does, we'll return something other than that. Otherwise, we will return the actual block. So let's see. Expected a semicolon. Oh, cool. And I made the null block 0 too. So that's kind of nice. Okay. Yeah, so I'm going to change this to 0. I forgot that. So I reserved 0, which is going to be sort of our null pointer. And the reason this is important is because if I reserve this as 0, we can basically say inside a chunk, we don't have to do this. We could just say if top index. Yeah, which basically just means if the top index is not null. Okay, cool. So that's really nice. Or actually, I guess we should say if not top index. So if the top index is not null or the block is transparent. Okay, cool. So yeah, that's why I reserve 0. But SE Woods, have I ever tried to program a drone or thought about it? Something you find interesting might do yourself. I have not. So I have a friend who's really into drones and like all things hardware. He majored in computer engineering. I'm mostly like software and stuff, and I really enjoy the higher level software things like languages and operating systems and stuff. So yeah, I want to get into hardware stuff. I saw Sebastian League's video where he made like the little console, which was really cool. So I eventually want to experiment with it. I have like an Arduino and all that stuff, but I've never gotten around to it. So yeah, but if I ever do, I'll let you guys know, and hopefully I'll do something good and won't like kill myself with a drone. Okay, but yeah. So reserving 0 is really nice because then you can do things like this. Kind of a good thing to keep in mind. And I learned that from a blog that I read. But anyways, yeah. And then we can also do something like this where we don't even have to do this because we can just return block formats block ID -1. And this won't... Wait, no, we can't do that. Okay. Actually, yeah, we can do that. Okay, so I'm going to do this. And then what we'll do is inside of here, we basically get the texture format. Okay, here we go. When we load the blocks, this is going to sort of load them in. And I'm doing this in a pretty bad way right now. It's just sort of pushing them. But what we can do is we can say wherever, yeah, block formats dot pushback, and then we'll just do a random block that's not true. And so this way the null block still doesn't return like a invalid index or something, like an index out of bounds or whatever. So yeah, good things all around. And can you use Visual Studio Code, or do you have to use Visual Studio 2019? You can use Visual Studio Code, which I would suggest if you have a little bit of a lower end PC right now. I like using Visual Studio just because the debugger is amazing. And it has some other nice features which you don't really get in Visual Studio Code. So, and yeah, that is a good question. If you're asking for C++, that's true. But like VoxelRiff said, if you're asking for something else, then that's probably a different story. So, but anyways, so we will just push back. I was looking for this. Just takes in textures and then whether it's transparent. So I'll do like empty string, empty string, empty string, and then true for transparency because it's a null block. Okay, cool. And eventually we could do this like paint it pink like Minecraft used to do, just so that we can immediately see that we have a null block in some area. Okay, anyways though, so that should be good. And then we can also change that. Yep, and that should be fine. Okay, yeah, cool. So that should be good. I'm pretty confident in that. So now our top faces should be cold if they have a block on top of them. So let's see if this actually works. Fingers crossed it will. Actually, it's not going to work. Yeah. I'm not sure why it didn't work. Actually, I'm pretty sure why it gave us that error. So basically, the reason it didn't work is because we're still doing this. And this is not good. Oh, and the reason it gave us that specific error is because of this. Yeah, so we're going to have to change both of these a little bit more to get this to work properly. Okay, so what's the best way to do this? I think I'm going to convert this to a function. That's probably the easiest way to get this stuff working. So for now, I'm going to do comment that out and that out. Let's make sure we didn't break anything. So if I do this, we should be fine. Okay, cool. So we are fine. It's still working. Let's abstract all of this stuff into a function. So what we're going to need is 4 positions and an index for that. Okay, so we'll say we need a function static void load block, and we need 4 positions, const glm vec3 position 1, or I guess vertex 1. So we'll do vert1 const glm vec3 vert2. Actually, I think we can just do a const vertex. Can I do that? No, I don't think I can. Okay. In the future, that would be nice to do. Okay, for now, we'll just do this though. Vec3 vert2 vec3 vert3, and then we also need an index. So int vertex cursor. Cool. So I'll just copy that and implement it down here. And we're going to abstract this logic and put it right here. So basically, we will just say vertex data, which we're also going to have to pass in. So what is vertex data up here? Vertex data is vertex pointer. Okay, so maybe I can do that, but I don't know. We'll think about that. Okay, so anyways, I need to do const vertex. Actually, that can't be const. So we'll just do vertex pointer, vertex data. Okay, and this is turning into a long function, which I typically don't like. So I'll probably change this in the future, but for now, this will work just fine. Okay, cool. So then we do vertex data, vertex cursor, and we will just do, instead of this, okay, yeah, this is a vertex. So change all this to vertex. Okay, there we go. And then we can just change all of this to vert. This is 1, 2, 3, and we need 4. So we'll do one more, and this will be const vertex and vert 4. Okay, cool. So we should be able to abstract this now. If I copy this up here, and I'll just do a semicolon there. Cool. So now we have that load block function, which we can basically change to, instead of doing this, we'll do something like load block. And this will take in verts 0, verts 1, verts 2, verts 3, and I missed something. I'll get that in just a second. And then vertex cursor. And this should be vertex data. Okay, so, and that should be spelled right. If I do that, this should do the same thing as this essentially. And then we'll do that. And if I run this, we should be fine. And the reason I'm abstracting this is we'll see in just a second. Okay, cool. So that's still working and we still get the top face. Cool. And you asked, Minecraft uses air blocks to check the faces. If there's no air block, the game draws the face. Am I correct? Yeah, I think Minecraft probably operates on something like that. So our null block could technically be considered an air block too. Yeah, it might be good to just have like an air block. I'll probably fix that off stream. For now, it'll just be called the null block. And then we'll make an actual null block, which is like anything that doesn't map to a valid block. So we'll do that eventually. Okay, cool. So we load the block. That's working fine. So now we can abstract this one too. And this is going to be 0, 4, 5, 1. So just change that to 4, 5, 1. And we can move all that. We'll load block 1, 5, 6, 2 for this one. So 1, 5, 6, 2. And the way I figured all this stuff out too is just by my diagram over here. It took us a while in the first stream that I figured out the correct indices for all this stuff. It's always the most annoying part of building like any sort of render is figuring out which order you need to put your indices to make sure everything works properly. Okay, so we got that. I'll copy that. This is going to be 3740. So 3740. We can remove that. And finally, we have 7654. Okay, 7, 6, 5, and 4. Okay, cool. So why did I just do that? It seems like a waste of time. First of all, let's make sure I didn't break anything. And yeah, you could just not use indices. I'm not sure if they're even helpful in this case because we are duplicating vertices and everything. Technically, we could probably just not use indices for this and it would work the same, but too late for that now. I already went down the path that I went down. Maybe I'll change it in the future with a lot of things. Okay, but anyways, I abstracted all that stuff because we are going to put all of this in there too. And as he would, you did some superficial research on multiplayer implementation and read something about model view controller pattern. Is that something you've heard of, Gabe? Is it something Jade Engine is set up for? Yep, I've heard of model view controller. That's a popular concept in like websites and stuff, where basically you have like a model, which is the data that's part of the website, a view, which is like the actual web page you want to show, and then a controller, which sort of marshals data between the view and the model. I don't know if we need to use the same concept for games, though. It's useful to have for websites, and even then, there's a lot of debate about whether you really need like MVC, or there's like MMVC or MVVC or all sorts of other stuff that people have come up with to sort of abstract it the same way. Since we're really concerned with performance, and especially multiplayer games, it's probably best to keep abstractions very low and just send like as little data as possible. That way, if you're on a server, you don't have a lot of lag since you don't have to send stuff. So I think what Minecraft does is they send like incremental updates. So they'll send like, oh, chunk update, change this block to this ID. And that way you don't have to regenerate like entire chunks and send over all the chunk data because that would take a long time. So we will look into all that stuff. And you don't know why, but you can understand English more than you can speak. I have no idea how that would work because I don't speak any other languages other than English. So I have mad respect for all you guys who have learned English as a second language and everything too. And yeah, no problem, Messy Woods. It's definitely a useful pattern too in web design. So if you're doing anything with websites, I would definitely take a look into it. Okay, and Jade Engine doesn't have support for it too. Forgot that. But anyways, we have all of this that we want to offload into here. So we'll basically do this. And we want to pass in elements. And what are elements? They are an int32 star. We want an element index cursor and an element cursor. So we'll say after the cursor, int32 star elements, int element index cursor, int element cursor. And I definitely need to do something better for this function, but for now it's going to work. So basically what we want to do is instead of doing this, we're no longer looping this. So we can just do that. And we can just do that. Okay. And when do we increment this stuff? I guess that's a good question too. So basically we set the elements. We go 0, 1, 2, 3, 4, 5, which is fine. So we're basically just incrementing this. And then what do we assign it to over here? So that's going to be like which element is actually going in. Okay. I think, okay, what are we doing down here? So we're basically just doing all of the elements, and then at the end of it, we're adding 24. And we basically will not want to add 24. We'll want to add however many we actually added at the end of it. This is a little bit tricky. So I guess what we could do is we could say const int element cursor up here equals, well, we could do like element cursor copy equals element cursor. Yeah. I think that should be fine. Wait. No, this doesn't matter. Okay. I'm overthinking this a little bit too much. So I think we should be fine to just do this. And then we can remove all this. And then we can remove all this. And we can just say element index cursor plus equals 6 element cursor plus equals 4. Yeah, that seems right. Okay, so we can move that out of there right here. Okay, I'm not sure if this is actually going to work or not, but we'll see what happens. And yeah, so let's try that. We will remove this. Scary thing to do. And then we'll just paste that, paste that, paste that, paste that, and paste that. Okay, cool. So if all goes well, we should still have the same thing. Let's see what's going on here. Oh, declared. Oh, okay. I have to redefine this to this behemoth. Okay, so let's go back up here, redefine that. Cool. And this is a forward declaration too, if you're not familiar with C. So it's just that we know that this function exists. Anyways, now I'm going to have an error down here. We need to also send in, so vertex, and then elements, element, index, cursor, element, cursor. Cool. So if I just copy that, we can do that, change that to a comma, and we'll just do the same thing for all of these too. All of that. Another one here. And last one. Okay, cool. So if we do this, we should still get the same thing. And you're going to watch my transmissions 10 times, learn C++. Should you do it? I would say no, because I program C++ in a pretty weird way. I'm making a series on my channel, how to code C++ for Java developers. If you want to learn like the proper way to learn C++, I would definitely watch that, because I'm trying to be conscientious of like best practices and stuff. Well, some best practices, but yeah. And why am I not using Java? Because C++ is faster, and I like C++ more, and I think that if you want to develop games, it's probably the best way, especially if you want to like get into an actual game engine company or like a game company. Knowing C++ will be a huge upside. if you want to do like tools programming or something. So I just think it's pretty important to know, and I like it, and I think it's fun. So yeah. But okay, so this is still working. So now we can do this magical if statement, and now we should have our top faces culled if all of this works properly. So if I do this again, no, we get this. Okay, so I'm still doing something wrong up here. Let's see what's going wrong. I'm guessing it's because of this function. So we get the index if, oh. Okay, wait, yeah. So if the index is greater than or equal to, that's the problem. Okay. Okay, so if we do this again, should be good. Nope, still bad. Okay, or index is less than 0. I think this is right. So if the index is greater than or equal to all that stuff, or it's less than 0, we return the null block, which is just 0, right? Yep. So that's good. And I'm guessing this isn't where we're breaking. So that means we're probably breaking right here or something. Oh, yeah, I think we're probably breaking right here. Okay, so we just have to move this into that function too. So this is just getting the UV set up. And it's no longer going to be the array expansion times 24. We can't really do this anymore, so we have to get a UV cursor too. Okay, so let's go here, int UV cursor equals 0. And we're going to do sort of the same thing we did with everything else. Instead of doing this and all of this, we're just going to move this into here. And we'll say texture format equals all of that. Okay, so it looks like we'll have to pass in the top, side, and bottom texture formats as well. This is getting to be a very big function. This is not good practice at all, but I will change it off stream. So yeah. And what is good integration idea with Java if you have 7 months to do? Yeah, I agree with Voxelrus. What do you mean by integration? Okay, so we'll say texture format side and bottom. And then we also need some I index, which is, oh, so this is just the face. Okay, so we should create like a face thing here. I'll go up to here and I'll create an enum real quickly. Cube face. This could be top, side, bottom, right, left, back. That's 6. 1, 2, 3, 4, 5, 6. Okay, cool. We're good. And I'll make this an enum class because otherwise C++ gets mad at me. So we'll just make that int 32. Okay, cool. So we've got the face. And we're going to, actually, I'm going to change this up a little bit. This will just be like texture, which should be good. And then we can just do, instead of all this stuff, remove that and just copy this texture. So we'll do that. And UV index now becomes, instead of this, int UV cursor. Cool. And why am I even using UV index? Wait a second. Because that doesn't make much sense at all. I should just be using the vertex cursor here, I believe. We'll see if this works or not. This might break. We'll find out. Okay, so copy that. Paste it up here once again, and fingers crossed this time we are actually going to be culling our top faces. Okay, cool. So now we're going to have problems here. That is fine. What I'm going to do here is, instead of all of this stuff, we're just going to, this is the top face. We'll give it the top texture. Okay, cool. So this is going to be simpler. Comment that out. This is the right face, so we'll give it the side texture. Forward face, side texture. Left face is side texture. Back face, side texture. And bottom face is bottom texture. Cool. So now if we run this, fingers crossed, is this going to work? No, it's going to error. Okay. I is undefined. We don't need this I anymore. We'll do that. And then I'm also going to remove that. Okay, cool. Yep, so we do that. And then we also, yeah, we shouldn't have to worry about vertex cursor because that's incrementing every time anyways. Okay, cool. So if we do this, no, we're still getting an error. Oh man, we're so close. We are very, very close, but not quite there. So what's going on? Will I do a cave system? Hopefully. And how will I handle the stairs? I talked about that a little bit earlier, but basically I just want to create something in the way we're loading the blocks, and there will be different block types. So you'll have like a stair block, a fence block, etc. And this will basically just change depending on what block type you're dealing with. So for now, we're just using cubes to keep it simple. And then once we get to more advanced stuff, we will take all that into consideration. Okay. But anyways, I have no idea which part is going wrong. I think it's this, but I'm not sure why. So if we just, let's do this. So if we remove this, let's see if we still get an error. Because right now, if we do, that means either this or that is going wrong. Okay, we do still get an error. Cool. So that tells me that it's probably one of these two. So is it this one or is it that one? Let's find out. So comment all that stuff out. Okay, so now we know which one it is. It's that one. I thought I had that taken care of, but I guess not. So we will remove that. Something is going wrong inside of here. So return block formats block ID. Well, which block ID is screwing us up? Here, I will do if block, I guess, okay, so technically what I should be doing is block formats dot at block ID, because that's probably the proper thing to do. This one we're fine because we know that we will get a valid block ID if this is valid. But for this one, we're not sure. They could pass in anything, and this should throw a breakpoint or something now since we're using the at function, which checks. Okay, yeah, so now we get a breakpoint. We can go into here, get block, and this is 5 coming from here, which is get block top index. I don't think I have a 5 ID, do I? 2, 3, 4. No, I do not. Let me just triple check. So go into here, inside of this one. Yeah, so we've only got 4 blocks. I'm not sure why I'm getting a 5th one. We'll find out in just a second. Why aren't I streaming on Sci and Tech? We talked about that earlier, but basically I didn't know that which topic was the best. I was looking for a programming topic and couldn't find one. So yeah, but I'll fix that in the next stream. And okay, cool. So anyways, we know what's going wrong now. We're getting some bad data, and it's coming from, let me run that again because I wasn't sure where that was coming from. It's coming from right here. Okay. How is that returning 5? What's top index? 5. Okay. I don't know how this is returning 5. That's really weird. Okay, so if we go back up to here, this is just returning null block, which is 0, or index. Oh, I'm stupid. That shouldn't return index. That should return, well, yeah, that should return index. Wait. What I wanted this to do is like get block, basically. I guess is what I was thinking, but this is returning an index. Let's change this to get block. And then we need the data, which is right here. So that's just an int 16 star. Okay. Yeah, so that's the data. And then we'll do that. So if it's that, we return null block. Otherwise, we return data index. Okay. Yeah, that makes sense. Okay, cool. So now we can change this to chunk data. Well, no, that doesn't make sense. Okay, so this one is 2 1D array. So we'll make two functions, okay? So this one will be 2 1D array, which just takes in that. And this will just return, whoops. We'll just return that. And then get block will just take in the data and then an XYZ, and it will return the actual block's ID. Okay, cool. So that's 2 1D array. And then this should be, instead of this should be get block data XYZ. Okay. And then we can remove that. And this will be, instead of this, block ID. Cool. And this is looking for data. What is data? Data is chunk data. Okay, cool. So we'll do that. Okay, now we should be good. That makes a little bit more sense. Let's run this again. Hopefully we don't get an error this time. And thank you, Flare YouTube. Okay, so we go back into here. And we're getting 5 still. Where's that coming from? Oh, because I haven't changed this one. Whoops. No, don't restart that. Oh, okay. Stop. There we go. Cool. So we go back into here. This should be get block now. And we'll do chunk data. Okay, now we should be good. Fingers crossed. Cool. You know what they say, like 20th time is a charm. Okay. So now if we go into here, yeah, cool. Wait, is this working right? No, I don't think it is. We should be getting the top. Oh, wait. Okay, we're getting the bottom faces cold. Is that right? Okay, yep. So that's down. If I look up, that doesn't work, but bottom faces are getting cold. Okay, cool. So do I just have this wrong? Oh, wait, or y+1 gives me the bottom face? Oh, that makes sense. That does make sense. Okay, what's happening? Why are we calling the bottom faces? Because I said top index equals y+1. And we say if we have a block above us, we're not going to draw the top face. Wait, that makes sense though. Let me change that to -1. Let's see what happens. I think we're probably going to get the same thing though. Okay, so if I go back in, yeah, we still got the same thing. Huh. So what's happening there? Okay, so we basically say top index, or I guess this should be, oh, yeah, okay. So this is the top block ID, and we'll say that. Okay, cool. And then we'll say top block ID. Okay, cool. So we're basically saying the top block ID is this X position, and then Y, it should be Y+1 is what I would expect. And then see, oh, wait, I think I know why we're still seeing faces. That does kind of make sense. So we are culling the top faces. It just doesn't look like that because if I look up, we still see it. And if I look down, we don't see anything. But that's because we're only culling the top faces and not the bottom faces. So I'm seeing the bottom face right here. Okay, so this is working. Cool. And how is it going? Cool. So if we do this again, except we do it for the bottom face, let's see. And we do all that. And we say bottom block ID. And we say bottom block. This is going to be Y-1. And we're going to use this bottom block ID. Change that. And change that. So now if we look up and down, we should see no faces. I look up, there's no faces, and down there's no faces. Cool. But if we were to go out here, we should still be getting the appropriate faces. Okay, let's do this for the rest of them. I'm pretty confident that this is working now. So I'll do the same thing here. We will do that. This is going to be the right block ID, and this is going to be x plus 1, and then this is going to be the right block, and we'll pass it that, and then we will pass it that and that. Cool. Copy that now, paste it, and whoops. Okay, do that. Cool. So then this is going to be the forward block ID and the forward block. We'll change this, change that, change that. Okay, do it again. This would be a perfect case for offloading all of this into that function, but that function is huge, so I'll probably change this to something better later on. Okay, cool. So then this is going to be the left block ID. This is going to be the left block. We're going to change this, change this, change this, and this. Okay. And I think I have one more, back face. So if we do this and this, nope, not that. Cool. And then this is going to be the back block, and this is going to be the back block ID and the back block. And then copy that, over that, over that, and over that. Okay, so now if we go back into here, we should be culling the inside faces. So we can see the outside, but we can't see that side or that side. I did something wrong. If we go inside, it's almost working. I think I messed up one of the faces. But am I using GLFW? I am using GLFW. And am I coding this with Java? I am not coding this with Java. It's C++. Yep. C++ is hard. It's not that hard. If you use a subset, if you use like a small subset of C++, it's not that hard, but it can be. Okay, so I have one of these messed up. This is back block. Yep, that's all good. Left block, that's all good. Oh, I know it. I didn't change the coordinates. Okay, so this is top block. Right face is x plus 1. Forward face is z plus 1. Left face is x minus 1. Back face is z minus 1. Bottom face is y minus 1. Okay, cool. So now if we do this, we should have the interior faces cold. We're so close. I'm just messing something up. Yeah, like, okay, it looks like I'm messing up. I don't know. Okay, check this again. Okay, so bottom is y minus 1. That's right. And that's all right. The back is z minus 1. That's right. And I'm not using... Okay, yeah, I am using that. Cool, so that's fine. The left is x minus 1. Okay. And forward is z plus 1. Yep. Okay, that all sounds good. And then right block is x plus 1. Okay, yeah. So that all seems right. I have a feeling we're getting these problems because of that null block, which is sort of what somebody was pointing out earlier. So I think I should have the error block in there. So we'll have to change this up a little bit. So let's go back into block map. So we've got the null block, which is there. And then we're going to push a formats. This is going to be our error block, which is also got nothing. Okay. So that's fine. Let's see. Okay. On second thought, I'm not going to do this for now. For now, we will just keep the null block, and instead I'll just remove all of that. So we'll just do that. So if it's transparent, wait, no, yeah, this shouldn't be a problem. Okay, I got to think about this a little bit more. But it's just okay, you want to be a programmer? That is good. Programming is fun. It can be a pain though. And you don't need to buy a course. Programming can be taught with just a book and a computer if you want to. Yeah, and lots of free videos on YouTube. Okay, so I've got something wrong with the way we're culling the faces, and I can't tell what's the problem. Let's look at this one more time. So it looks like we're culling some of the faces, and it looks like it's going, yeah, so it's definitely doing the right thing for this corner block, but then it starts messing up for all of these blocks. Let me see if it's doing the right thing for the bottom part too of this corner. Because if it is, I think it's probably just something with my indexing. Okay, yeah, so it's even got the bottom face of this block too. But for some reason it's showing that face, which it shouldn't. Okay. So I have something wrong with the side faces, I think. I need to figure out which side is which, because I can't tell what's forward and back and what's left and right, which isn't good. But I think it's definitely got to be the X, Y, Z axes. So let's go ahead. We'll add in the X axes real quickly just so that we can tell which ones those are. So add in all right faces and left faces. Yeah, because I think I might have made X forward and backward. Okay. Cool. So that fixed a lot of things, but we're still having some problems. Okay. Yeah, I think I just have my X and my Z's mixed up. So if I do this, it looks like Z is left and right and X is forward and back. So we'll do this. +1. Forward is going to be X +1. So we'll do that +1. And then left is going to be Z -1. And back is going to be X -1. Okay. Hopefully this will fix it. And if it does, then that's just a lesson to make sure that your coordinates are all aligned properly. Okay, so it looks like we're getting this one right now. Almost everything. Wait. And then we get this side. It's really close. Just not quite right. Yeah. So did I mess something up here? Okay. Back face is X -1. Yep, that sounds right. Left face is Z -1. That sounds right. Forward face is X +1. That sounds right. And right face is Z +1. Okay, that all sounds right. Do I have my right faces and my side faces mixed up too? Let's just do an experiment. We'll change that to -1, change this to +1 and see what happens. Because I have a feeling my axes are just all sorts of messed up. And do I have a set limit of blocks in my index? I do. I just have like 256 blocks for now, which is sort of the Minecraft standard. I will probably change it afterwards though. Okay, so that definitely does not look like it helped. I think my X's are messed up. So let's go to forward face. That's going to be -1. Back face is going to be +1. Okay, let's see if that works. Fingers crossed. Oh, okay. Not sure what's going on here. Okay, wait. So, okay, no, X's were right is what it looks like. I guess Z's are wrong, but I just did that and that didn't really work. I got to figure out what's going on here. So we'll go back into here. Yeah, I think this side is X and I think that's Z. And then this side is also X. And that's Z. Okay. Oh, you know what it is? It's probably my indexing right up here. So I'm using Z here. Let's switch that to X and that to Z. Maybe. Just kind of trying random things. What does culling mean? It means removing the interior faces. Yeah, okay, so that's not working either. So if you like saw the beginning of the stream we basically just had all of these block faces inside of here. And so now when I go behind it, it disappears, which is sort of what we want to happen. So culling just means we're sort of removing those because it makes it easier on the computer. Okay, change this back to Z, change this back to X. And I have to figure out what coordinate axes are what. So this is where we set up the vertices. And these vertices should align with this picture. So we should have like 0, 1, 2, 3, 4, 5, 6, 7. That's how it should look, which means that the way I program this, X should be forward and Z should be right. Positive Z should be right, supposedly. But I'm having doubts about that. So let's go back into here. I'm going to try this one more time and remove this and remove this so that we have all forward and back faces showing, just so that we can figure out what's what. Okay, so with that removed, let's also remove the left and the right faces completely. So I'm just gonna remove that and remove that. Okay, so now we can figure out which direction is which and make sure that this is all working properly. So, okay, cool. So this is the X direction going this way. So what I believe, yep. So this is like forward and back. So I'm going like backwards here and then forwards. And it looks like this is all working right, because if I look on this side, we have this face, but then if we look back this way, it disappears. And then if I'm on this side, I have this face, but if I go the other way, it disappears. Okay, cool. So that's all fine. Let's see if I remove this, does it still work? And we also need to undo that. So that's forward. And then this is back. Okay. And you guys would have thought that I would have learned something, because at the beginning of the stream, I was like, I should do stuff incrementally. But yeah, I clearly did not learn that. So we've got this face, it's showing. That's good. And it looks like it's showing for all the faces. So then if I keep going this way, okay, yeah, cool. So I just ran into the other face. Okay, so X is working fine. Now we have to do Z. Let's see what's wrong with Z. So I'm going to uncomment this, and then we're going to comment this one out. Control / come on. There we go. Cool. And then uncomment this and comment this one out. So now we're doing the Z faces. Let's see if that works. And this is where I think we're probably going to have a problem. And Java is a pretty fun language, so I'm glad you're learning it in school. That's pretty cool. Okay, yeah, so we definitely have a problem with the Z faces, because you'll see that we only have one. And that's not right. So what am I doing wrong here? Let's first of all remove this and remove this. And let's see if we get some basic stuff. And then we'll remove this and we will remove that. Cool. So if we do this, we should get the whole chunk face for Z's. Cool, we do. So we get that face and we get that face. And then if I look behind it, yep, that's cold. Okay, cool. So that's definitely left and right, which is Z, and then X is sort of forward and backwards. So we just have this part wrong. So if I uncomment this and this, this should just cull right faces. Let's change this to Z -1 and let's see if we get anything that looks right. So we should just get one side culled. Okay, so we still get a face. Okay, cool. And yeah, it doesn't look quite right, because if we look behind us, we can still see this face. Wait, can we? I can't tell. Yeah. We can still see this face, which is really weird. So I think we're culling this face, but for some reason, we're culling everything except for this one. And that's just really weird. Okay, let's try +1. Let's see what happens when we do that. Okay, so if we do that, okay, there we go. So now that's, wait, nope, now it's happening on this side. Okay, so now we just get this one. but the rest of them are disappearing. That's not good. We should be getting the whole thing. So what the heck am I doing wrong here? That's really weird. It's got to be this get block function is what I'm thinking. Because yeah, all of this stuff seems fine. And this get block function is operating on the assumption that all of this is set up correctly. Oh, maybe I should change this to Z, this to X, and this to Z. Same thing here. Okay, let's see if this fixes it now. I didn't realize I was using two different functions for that expansion. Okay, so now that's fine. Okay, there we go. We're back in business. Okay, cool. So I was stupid. This should just be 2, 1D array, X, Y, Z, and that will be int index. Always use the same function for things because otherwise you'll change the wrong thing and think something's wrong. But yeah, what happened there was basically the way I was expanding the array, I had the Z and the X messed up. So when I was going from 3D to 1 dimension, it just wasn't looking in the appropriate place. But now that we do that, we should be able to uncomment all of that, uncomment all of that. And I believe, so this is Z minus 1. And so we'll do right face is Z plus 1. Cool. Okay, cool. And then we will also uncomment all of that. And top face, right face, forward face, left face. Cool. Okay, so then if we go back in, we should be good. Hopefully. Oh man, you're kidding me. We just had that fixed and then it's broken again. I think it's broken for the X's now. Okay, so if I just get rid of the X's now, which were X plus 1. So if I just comment that out and comment that out, we should be good. Okay, yep. So the Z faces are working now. It's just the X faces that are broken. Yep. Okay. So I think I have something funky going on in this expansion. Let me just double check my math on this. In the last stream, I sort of did something to kind of make this easier on myself. Let's see if I actually saved that, which would be good if I did. Okay, so if we go to repositories, this is my GitHub, where you can find the code for this if you want to sort of see how I'm building this. Let's see. If I go into world, did I save it? Well, it would actually be back in the commit history a little bit. Let's see. Let's go to the history, and I'll go here. No, it doesn't look like you saved it. Okay, I was looking for a comment that I used. That would be pretty helpful right now, but it doesn't look like I have it. Okay. So let's just sort of think about this and make sure that I'm expanding this right. If we have X, Y, Z, and we think about this in terms of like a 3D array, I basically want to go from 3 dimensions to 1 dimension. And this always annoys me. Here, let's go back to the drawing screen because I've got some stuff written down. So if we take a look at this, this is where it gets math heavy, and that's why I always mess up. If we imagine this is like the height of our chunk, this is the depth of our chunk, and then this is the width of our chunk. We basically have 3 arrays, right? We have one array going this way. We have, and then that array kind of goes backwards through the depth, right? And then it goes down and then it goes backwards through the depth. And we basically just want to figure out how do we go from a specific XYZ coordinate in here to just a number. So we're basically, this would be 0, then 1, then 2, then 3, then 4, so on and so forth. And then the next one would be like 5, 6, 7, and then go back. So the way that works is if we have X, Y, and Z, Z is the depth, X is the width, and let's say we have 0, 0, 0. This should map to 0. Okay, so this should equal 0 is what we want. And then when we go 1 in the Z direction, this should be 1, 2, would be 2, so on and so forth, until we get to, I'm going to say 1 in the x direction. And then that would be like, since we have 16, that would be 16. And then we'd get 0, 1, that would be 17, so on, so forth, until we get to 1 in the y direction, and then that would be 256. And then we would get like 257 with 1 there, and so on. So yeah, we basically just have to make this work. So that basically means that for every z that we get, we just add 1. So we basically just want a plus z. For every x we get, we want 16. Yeah, which is just chunk width. So that would be x times the width. For every y we get, we want 256, which is y times the width times the height. Because 16 times 16 is 256. So this is what our formula should be. Let's see if I can fix this. So we'll go back into the code. And let's change this up to match that. So I'm just going to remove that real quick. And then we'll say return y times width times height. So y times chunk width times chunk height. Or I guess this would be, yeah, chunk width times chunk height. Is that right? No, that's not right. Y times chunk width times chunk depth is what I think I meant. But that's not right either. That should just be height. Okay, so y times height plus, I think this is probably going to be wrong. We'll have to revisit the math in a second. X times width plus z. Let's see what happens. I have a feeling this is just going to be all sorts of wrong, but we'll see. Yeah, so we're getting nothing right now. That's probably because this just isn't working. Okay, let's go back to the window because I have to draw a little bit more to get this figured out properly. I'm just going to scroll down. So we want XYZ to map to some value like 0, 1, 2, so on and so forth. Okay. So 0, 0, 0 should go there. 0, 0, 1 should go there. So if we have 1 in the z direction, and I should actually make these line up right. 0, 0, 1 should go to 1. 0, 0, 2 should go to 2. Okay. And then there's 16 for z. So then we would eventually get to 16. So dot, 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 0, 0, 16. Or I guess that would be 15 since we wrap at 16. So that should be 15. And then we would wrap 1 in the x direction. Then this would be 1, 0, 0, and that should be 16. Okay, and then that would be 1, 0, 1 would be 17. Okay, so then we go dot, dot, dot. Then we would go 0, 1, 0 eventually. Or actually, I guess no, I should do this a little bit differently. Then it would be 15, 0, 15. So that would be 15 times 16 plus 15. I'm getting a calculator out for that. And let's calculate that real quick. So 15 times 16 plus 15 is 240. Wait, no, I did that wrong. 15 times 16 plus 16 is 256. Okay, cool. So that makes sense. So then we would get 256 here. But does that make sense? I think it does. No, that should be 255. I added the wrong number. Okay. So that would be 255. And then we would go 0, 1, 0. And that should be 256, which is the height. And then we would go 0, 1, 1, which would be 257. and so on. Okay, yeah, so that all seems right. So then that would be, so we're just going to have the plus z like I talked about. And then for the y direction, that's just y times 256, which is just y times height. Okay, and then for the x direction, we're just going to have x times depth. So x times depth. So x times depth plus y times height plus z, which should give us the correct. And then we have to loop going z, then x, then y whenever we loop in order to get this to work the correct way. Okay, so go back to coding. And I do pay attention to chat. I just have to check it every now and then. I am streaming from Streamlabs. You can sort of see it down here too. And so, yeah, we have a Discord link too. I'll put that up here so that you guys can see the Discord link, or I guess, I don't know, I'll put it in like a description or something if you can. It's in the description of like most of my videos and stuff too. But yeah. And yes, I am in focus mode. So let's see if I can get this done now. So change this back to return x times chunk depth plus y times chunk height plus z, which might be the same thing I just had there. But anyways, we just have to make sure we're looping correctly. Should be z first. Change that. Wait, no, that's wrong. Should be z last. So we'll do z down here. And then this will be chunk width. And then this should be x next. And this should be chunk depth. And then this should be y. And that should be chunk height. Oh, cool. Thanks for following. Danks Ubio Gamer. Hopefully I said that right. But thank you for following. That's cool. Okay, so if we have all of this set up correctly, I'm going to copy this really quickly. Go back down to here, copy it. Cool. Let's see if this works out. Okay, and you're new to Twitch. I am too, so we're in the same boat. Don't worry. That did not work. I don't see anything. So I must have messed something up pretty bad. Let's go ahead and just stop culling stuff because I need to see what we're doing. Okay, so we'll remove that. Remove that. Add that back in, except not that part. And remove that. And finally, add this back in. Well, I guess just this part. And remove that. Okay. And that. Cool. So hopefully we'll at least get a cube again, or a chunk. And yes, I am not affiliate, so I don't have subs. I need to like meet a few different other requirements for that, which hopefully I'll be getting pretty soon. But yeah, I have to stream a lot more and stuff. And yeah, I know I got to stream like 7 days in a month and then 8 hours in the month. I think I've got the 8 hours, but I just need to stream like 3 extra days. So there will be 3 bonus streams sometime. Hopefully we can get this working though. So if I go into here, okay, cool. So this is all working fine. I just have to figure out how to get these interior faces removed correctly. I'm going to do this systematically this time to make sure I'm not messing anything up. So first of all, I think I can confidently remove most of that stuff. I'll remove it later though, because I'm not that confident. Okay, let's do the top faces first. So this should remove all top faces. Let's see if that works. So if I look in to here, if I actually go into the chunk, okay, so I still have the top face, but it removes the bottom faces. I'm not sure if that's right. We should still have a bottom face on the bottom of this and then a top face on the top. So if that's right, I think it's okay. Okay, yeah, so we still have the bottom face. Let's just make sure we have a top face too. So I'll go up to the top. How long will this stream last? Probably only for another 20 minutes or so. I want to get the interior faces cold, which will hopefully be pretty soon. And then once we get that working, I'm probably going to end this one, and I'll have to save the procedural generation until next stream. I have a bad habit of misestimating or underestimating how long things will take. Okay, anyways, we've got the top faces though, and the top face is cold. So if I look up here, the top face is gone. Cool. So that's good. Then we want to get the right face, or not the right face, but the bottom face. I'm doing this systematically. So bottom face now. We'll do that. And I'm actually going to go ahead and move this right next to the top face since they kind of go together. Okay, cool. So now we should get the bottom and the top faces cold. Am I verified on Twitch or not verified? I think I'm verified on Twitch. Just not Twitch affiliate yet. So got to work on that. Okay, so we've got top and bottom faces. That's good. So we should still have top face up there. Let's see. And then we should have the bottom face too, hopefully. Okay, yep. So we still got the top face. And then if I go back down, we should still have the bottom face too. And we still have all the side faces too, which is good. And yes, Minecraft. Not really though. It's still a very long ways away. Hopefully not too long, but you know. Okay, so the bottom faces are cold. And we still have the bottom face. Okay, so that's working. Next, we'll try the right face. So uncomment that and that. And it doesn't like something. Oh, I accidentally did something weird there. Okay, there we go. So uncomment that and that. And then let's get the left face up there too, just so that those are all together. Okay, cool. And then fix that and that. Okay, so this should cull all the right faces. Let's see if that works. So we've got all of the faces on the outside, which is good. That's how it should be. I don't know what just happened there. Let's try that again. I think it restarted the program for whatever reason. Okay, so we've got all the faces. That's good. That is good. Nope, that is not good. Okay, so immediately something is wrong here. And I'm not sure what. Oh, you know what it is? It's this. This tricky thing. You guys, I'm really mad at myself because I should have realized this like an hour ago. Tell me if anyone can see what's wrong here. I won't be surprised if you can't because it's kind of hidden in there. And it didn't just hit me till like an hour later. But you know what's wrong. So let's go back to the math real quickly. Let's take a look at this math. So if I go out of bounds with x, say I get like x is 17. Which index are we going to get here? Well, if we just follow this formula and we say x is 17, 17 times 16, or actually let's do z. So z is 17, right? So this would be 0, 0, 17. What does this evaluate to? It's 17. Well, 17 is inside of here. So that's a valid number. But you know, 17 is not a valid z index because a chunk only has 16 by 16. So what we have happening is we're getting like a block there, but it's not the block we're expecting. What this should say is, yes, we can check for that, but we should also be checking or if x is greater than or equal to 17, or x is less than 0, or y is greater than or equal to 17, or actually I guess z is greater than or equal to 17 or 16, or z is less than 0, or y is greater than or equal to 256, or y is less than 0. That's what we should be checking. Let's remove that garbage. Let's do this, and then this should be 16. And I have a feeling we're going to see the correct thing on screen now. So if we do this again. Okay, so we've got that side. We have that side. We have that side. And we have that side. But if we look inside, it's cold back there. Okay, so what lesson can I learn from this? I have no idea. Let me know if you guys know a lesson that I can learn from this. So yeah. Am I following Dave Fampton? His game looks awesome. I am. And his game does look awesome. Dave Fampton, for those of you who don't know, yeah, he's a indie game developer on YouTube making a game called Sapiens. And it's basically just like a I think it's like Civilization, right? So like Civ, that game. You basically are just like a sort of a third person, and you're like inspecting the world, and you basically grow a community and stuff. Somebody else can probably explain it better. If you actually watch his videos, he explains it really good, and it looks really awesome, and he's coded everything himself, which is pretty cool. So yeah. Okay, check it out, guys. After way too long, we have the correct result. If I go inside of this chunk, I see nothing. No matter where I look, I see nothing. And that's because we have culled the interior faces. Yeah, man, that took way, way longer than it should have. Yep, we are finally there. So because of this taking so long, I think I'm probably going to end the stream right about here, since this is a good spot. If you want to take a look at the code, I have the code available on GitHub. You can just go github.com/codingminecraft. So if you're interested to see how I'm doing this, and then go into repositories, and this is the stream Minecraft clone. All the code is here. I'll push the update. I'll do that right now just so I don't forget. So if I go ahead and just do this, we'll add these changes, and we'll say, what did we do in this stream? We cull interior faces. So then I'll push that so that you guys can have access whenever you want. And let's just get that in there. Cool. Yep. Awesome. Cool. So now if you guys look in this, you should be able to pull the code and do whatever the heck you want with it. I don't care what you do with it. So yeah. But anyways, new operator to be famous. Okay, cool. So thank you all for coming to this stream. I had a lot of fun, and we're making some good progress on the game and everything. So hopefully we'll be in a pretty good place by next stream. We're actually going to do procedural generation in the next stream with Perlin noise and stuff. So thank you for following, Langors. And hopefully I'll see all of you guys if you can make it at the next stream, which will be next week at 9 a.m. Central Standard Time. If I do extra streams, I'll probably leave a notification on my YouTube channel. And if you didn't have a chance to watch this whole stream, I have a separate YouTube channel called More Games with Gabe. So you can go check that out. It's linked now in most of my descriptions and stuff of my videos. So you should be able to find that. Okay, but thank you for coming to the stream, guys, and I'll see you next time.